Hi, and welcome back to Applied Machine Learning from Analytics Vidya. In the last couple of videos, we have seen how linear models can help us build predictive models where the underlying relationships are linear in nature. And in order to build these linear models, we need to understand or find two optimal parameters, beta and b. And the way to do it is by using a technique called gradient descent. But before we actually get into the nitty-gritties of the technique, let me help you develop an intuition about what it is trying to do. And in order to do that, let me take you through a very interesting example or a very interesting competition which we do at times at our office, where you have a paper ball. So you have converted paper into a ball and you have to throw that into a basket. Right, so each of us take turn in order to do that, and whoever is able to do it first actually wins the competition. Now, in order to do this, what would you do? So assume you are playing this game. How would you approach this problem? So typically what people do is start with a value which they think might be the right strength to throw the ball from the distance where you are standing. So you take a random guess. So in this particular case, let's say you think that if you throw the ball with 30% of your strength, it will reach the basket. And you do that. But what you see is that it actually falls short of basket. So this is the error which you have made, which is represented by the peach color. And what you do is you take this feedback and then adjust your strength accordingly. So because it fell short, you need to increase your strength. And instead of 30%, you think that maybe you can use 50%, and you go and throw the ball with higher strength this time. And let's say that it actually crosses over. So you have missed the basket this time. So what you do is you now adjust your strength back, but not all the way up to 30%, because you know that 30% actually doesn't help you reach the basket. So you make some correction and maybe throw it by 45%, and you end up actually throwing the ball into the basket. You have actually done is you have started to solve the problem by a random initialization, whatever was that number which you thought was the right number to start with. And then you created these predictions, or you created these experiments, took the error or the cost into account to adjust and iterate. And you do this until and unless you are able to send this ball into the basket. Now, gradient descent actually works in exactly the same manner. So what it does is it is basically optimization technique which helps you find the minimum error. And the beauty about this technique is you can actually start at any point. So similar to the problem where you can start with any percentage of strength, you can start at any point in this curve for a particular value of beta, but you continue to update your beta and iterate over it. So the errors are minimized by working iteratively towards the point where your errors are minimized. So you make a prediction, you see whether the value of error is minimized or not, and then you again go on and update your iteration. So the model optimizes your parameters, and that gives you the optimum value of the beta and the b parameters. And this process goes on iteratively until the model converges to the minimal cost. In the next video, we'll look at actually how this gradient descent works and the underlying mathematics. Thank you.